Excellent. Hey everyone. Good morning, good afternoon, good evening, wherever you are. Welcome to our webinar called Top Takeaways from Google Next, all about GCP, Google Cloud Platform. Today we are planning on taking a look at the technology and solutions that have come out of Google's yearly event called Google Next. I have today with me Rich Fultak. He is our VP of Cloud Technology at Dido. My
Hey
name is
everyone.
Andrew. Hey, my name is Andrew. I head up collaboration and cloud projects here at Dido for the West. Dido is a leading cloud partner specializing in Google's technology to deliver guidance, services, and support. And we've been in the Google Cloud world and the Google world for about 10 years now. Since we work across different product solutions and lines of business within Google Cloud, we are able to serve as a single go-to partner for our customers to support them not only in Google Cloud, but in G Suite, in Chrome, and in Google Maps. So to get right into it, here are the top items from Google is releasing and to expand upon. First up, confidential VMs, BigQuery Omni, and assured workloads are all going to be covered in greater detail. We think these are kind of the highest priority or the biggest releases of 2020 and 2021. So we will highlight why these matter in terms of business use cases, what problems they can help solve in your 2020 and 2021 technology initiatives, things like that in a few slides. Google announced significant investment into accelerating cloud transformation with as-is VMware workloads to Google Cloud. So if you require on-demand burst capacity, or if you're looking to move workloads including DR, disaster recovery, backup, or VDI to the cloud, you can lift and shift workloads without having to refactor or re-architect your applications, obviously with huge savings and efficiencies gained in that process. So compared to other public clouds, Google has made this very attractive, not only from a licensing perspective, but also from the advantage of being able to more easily tap into things like Google's data analytics platforms or other pieces of Google Cloud. Number 3 on that list, streamlining retail operations with recommendations AI. This uses pre-trained machine learning to deliver personalized recommendations that suit each customer's tastes and preferences. That would be the end customer. With Black Friday and the holidays coming up, this is a big motion for a lot of companies. Google also announced updates to their open, hybrid, and multi-cloud enterprise network. Hybrid networking allows you to leverage Google's private network on a per workload basis. So no matter your situation, your company size, your budget, or your specific cloud needs, Google Cloud has a way for you to leverage the cloud in a way that works best for you. So from high performance options such as dedicated interconnect and partner interconnect to Cloud VPN for lower volume needs, or even direct and carrier peering options, they have a solution for connecting your infrastructure to a cloud that fits your needs and your footprint. They also announced 100 gigabytes dedicated interconnect is now in GA, so you can connect up to 8 100 gigabyte transport circuits for private cloud traffic to Google Cloud at the point of present locations. High availability VPNs are now available, and this is the lowest downtime in the industry right now, that being 53 minutes of downtime per year or 99.99% uptime. This is mainly for mission critical workloads, but that is the highest available downtime in the industry. In the BigQuery world, Google announced some changes coming to BigQuery, their modern data warehouse. They announced that same 99.99 uptime SLA, which is the highest available cloud data warehouse in the market. There's also no extra charge to all customers that are using this or taking advantage of this SLA. They also announced significant speed improvements, so it's even faster than it was previously. 1 terabyte, querying 1 terabyte is now 19.2% faster compared to last year. 10 terabytes is 28.4% faster, and 30 terabytes is 19.9% faster. Looker's roadmap for 2020 and beyond. Google completed its acquisition of Looker in late February of this year. It can fully leverage modern databases, can act as a single source of truth that makes your analysts' knowledge available to all of the organization, and supports an incredible amount of tooling integration and third-party connections. It also seamlessly integrates with many Google Cloud workloads for data visualization. And the last thing on this list, ML and AI. This is actually week 8 of the week 9 event, so we're going to have to say stay tuned for that one. And I'm fully assuming we'll have a presentation to cover that one as well. So one of the 3 focus areas that we're going to focus on today is BigQuery Omni. And first, I want to define what is BigQuery. BigQuery is a serverless, highly scalable, and cost-effective multi-cloud warehouse designed for business agility. So Google announced BigQuery Omni, and you can now reach out across data silos. You don't have to move or copy any data. You can use existing databases in AWS or, coming soon, Azure with the native BigQuery interface. To explain how this works, I'll need to highlight Anthos. Anthos lets you build and manage modern hybrid applications on existing on-prem investments or in the public cloud. It's built on open source technology pioneered by Google, including Kubernetes, Istio, Knative, and enables consistency between on-prem and cloud environments. Anthos compute clusters are run on AWS, for example, or Azure when that is available, and only the query data is passed through GCP. So your AWS data actually stays in place. The control plane and the metadata can remain on Google Cloud, but only the query result passes through the BigQuery routers and then Google's secure connection to AWS or Azure. The key piece here is it's a choice. You can bring them back, or you can do everything from within AWS if that's what you're used to doing. BigQuery Omni is a fully managed service, so a question that I have already heard is, so I have to use or spin up my own Anthos clusters or spin up my own compute to do this? And the answer is actually no. So Google has that covered. You do actually need your own storage and your own databases, and it's really critical that you maintain the access controls to that storage. But with the compute resources running locally, all of that is done behind the scenes, and you can just answer or query those questions. And then just to get a little deeper, the query is passed to the other public cloud, and all of the compute is done within that public cloud region. The results are returned to BigQuery UI, or you can choose to export the results directly back into your data storage on whichever public cloud you're using, which means there's no cross-cloud results of data. You can start using Omni right away. There's no need to do any formatting, like I said before, or copying of data. It supports Avro, CSV, JSON, ORC, or Parquet. You don't need to do any cluster management or reproduce any resources. All computation occurs within BigQuery's multi-tenant service, which is running on the region that your current cloud is running on. Google gets the data when your data storage within your account is authorized via your other cloud's IAM rules. Google maintains a secure connection to bring the results back to your cloud. So in summary, BigQuery Omni allows you to break down data silos to get straight to getting insight in data analytics. Having a consistent cloud experience across clouds is the second, major point. It doesn't matter where your data sets are, you should be able to use standard SQL, the BigQuery interface, write queries, build dashboards, and accelerate your time to insights. There's a statistic that says 81% of companies have some part of their business on more than one cloud. So by bringing the data to you, Google brings the compute to where your data is. Google manages the infrastructure, you focus on driving the business, doing some really cool data science, and not worrying how to set things up. So that is BigQuery Omni. And I'll finish this with a quote. The cost of moving data between cloud providers isn't sustainable for many businesses, and it is difficult to seamlessly work across clouds. So Google's general manager and vice president of engineering for data and analytics said, BigQuery Omni represents a new way of analyzing data stored in multiple public clouds, which is made possible by BigQuery's separation of compute and storage. By decoupling these two, BigQuery provides scalable storage that can reside in Google Cloud or other public clouds, and stateless, resilient compute that executes standard SQL queries. Until now, though, in order to use BigQuery, your data had to be stored in Google Cloud. That has now changed. So that is BigQuery Omni. I will now hand it over to Rich to talk about confidential computing.
Thank you so much, Andrew. For decades, a fundamental pillar of security has been end-to-end encryption. The main security control for this is fundamentally about maintaining confidentiality and integrity of the said data. even over environments not within your purview. So as data is stored, transferred, and processed, the ability for unauthorized parties to peek underneath the hood and learn your deepest secrets, or worse, try to modify sensitive information for some nefarious reasons, has actually grown over time. Because there's simply too many parties involved in the whole supply chain that manages your data end to end. Today, with the extensive use of SaaS solutions, public cloud computing, private clouds, internet service providers, stitching your environments together, the owners no longer have physical control over the physical assets being used to deliver a service. You really don't have that level of visibility or control over it. They basically transferred that control over to other parties. So what do you do to protect this data? And it gets even worse because various regulatory requirements have actually explicitly called this out, where data must remain encrypted to ensure confidentiality and integrity for that data is always maintained. PCI is one example of this, but there are many more, including high trust for HIPAA and so forth. So how does this really work, underneath the hood? So let's discuss the various types of data handling so people could understand this. Encryption in data or in transit has been around for a very long time, from the advent of the early internet protocols. The reason is actually quite simple to understand. Early computer networks involved connecting two different universities or research locations over an untrusted long-distance network. And so as such, protocols such as IPsec have evolved to encrypt data at the underlying IP packet layer between two networks using a shared secret key. And this is still in use today. It has not gone away, but just be aware that it's one approach to securing your communication flows. And this ensures that if someone were to listening in on the communication over that channel, say you had someone at AT&T or who knows who, right, what was able to kind of tap into that communication channel, they couldn't make sense of it unless they had that shared secret key. Now, over time, this synchronous secret approach was simply unscalable to deal with the plethora of applications to application communication requirements of modern environments. As such, asynchronous secret key management solutions such as SSL and TLS have developed. And this is really what you use to access most of your websites when you use HTTPS. And so the way it works is that the asynchronous encryption communication, as it starts, negotiates a shared secret session between the two endpoints. And really, that communication channel is unique from all other communication channels. You have a very different secret than everyone else. And today, both methods are still widely used to encrypt and process data as it moves from one location to another. Now, for data at rest, various protocols have evolved over time to encrypt data. And today, the default standard for encryption at rest is AES 256. In fact, at Google, that happens by default. In other words, if you store anything within Google, they automatically encrypt your data. They don't even give you the option not to encrypt your data. And the primary reason for this is that as a data owner, if someone were to have physical access to that data or manage to duplicate that data off these devices, they wouldn't be able to decipher the data unless they also had the various secrets, or even gets a little more complicated than that, because depending on the storage medium, you could actually have only chunks of your data in one place versus another, and each of them would have different secrets associated with it. So it's actually quite complicated in the way things are actually stored internally. But the idea here is, even if you know the algorithm, the reality is without the one or many secret keys that are needed to actually break down the encryption, you just can't read the data. And so that's one of the fundamental pillars, that if you manage to steal a database and it's encrypted and copy it onto another device, it will take you years or millennia to try every possible combination using brute force methods to figure out what is that data underneath the hood. Now, the missing link in the last 30 years has been the computer itself. An individual with physical or even virtual administrative access to that computer is able to take a running snapshot of the entire process memory. This technology is actually widely used today in forensics or simply for debugging processes and crashes along with other use cases. This is not, spy stuff or anything to that effect. Everyone has access to these particular tools. But what it really means is that it allows someone to gain indirect visibility of the data while it's being processed by the computer, because the computer actually has to decipher and decrypt the data while it's processing it, and as such, it's in its raw, unencrypted form in memory. And so if it was processing sensitive data, that sensitive data would likely be available in raw form on the computer's memory. And someone with the right skills having access to that memory snapshot would be able to gain some visibility to your secrets. So what does this mean when you host your computers in someone else's environment? Private clouds and public cloud platforms are being used to run highly sensitive applications with secret information all the time today. And how companies, so how are companies 100% certain that there is no rogue individual at AWS, Google, Azure, or any other private cloud provider that they're outsourcing this activity to, are not taking snapshots of your virtual computers and then running these forensic tools on them, gaining some visibility? I know it's not an easy thing to do, right? To get your secrets, go through these assets. But the reality is the blast radius that is extended by what that computer holds is actually quite extensive, and the compromise can be quite significant. And this has been one of the main reasons many highly sensitive governments or enterprises have resisted outsourcing some of their workloads to third parties. So be aware of this. And so now that Google just introduced confidential compute to tackle this concern directly, confidential computing environments keep the data encrypted in memory and elsewhere outside of the central processing unit. Basically, this technology ensures that not only that only that individual CPU is able to decrypt your data for processing, as it is the only entity that is encrypting it in local memory space. You cannot take a snapshot of your environment and really do anything with it, as only that CPU is able to make sense of that data. Now, these confidential VMs are based on Google Cloud's ND2 series instances, and they leverage AMD's secure encrypted virtualization features. Basically, the encryption is done inside AMD's second generation AMD EPYC CPUs. This is an actual hardware solution, and it is not portable. So in other words, you cannot take this information, move it to another machine, and make any sense of it, because it is only possible to be decrypted on the original CPU that you've taken your information from. So the idea here is dedicated per VM encryption keys are generated in the hardware, and they are not exportable. Now, there are some use cases that you may say, oh, that prevents me from doing X or Y, but the security implications, the value that it creates for really confidential use cases is significant. Now, the first thing I did when I heard about this was, okay, well, what about the performance? Okay, you're killing me here. It's like if you have to do this encryption. But Google has actually shown their CPU performance impact is only roughly about 2% compared to CPUs without this capability. That's negligible. It's noise in the whole scope of things. And so the idea is these CPUs could be used to replace existing GCE or even GKE Kubernetes environments. So you can run your workloads knowing for a fact that just because you moved your environments to Google, which is a third party, and even if they were nefarious employees, which again, they have processes to make sure that doesn't happen, but even if you're paranoid and you're concerned about it, know for a fact that it is impossible even for Google to have visibility into the environment as this architecture is built out. So this is really for those clients who want that absolutely highest level of security. They can truly now encrypt their environments end to end, which has been the missing link in this entire environment for decades. And all in all, when we talk with our clients, the reality, this is a game changer in terms of cloud security. Now, moving on to another I won't say it's a game changer, but if you're in government, it probably is. Assured workloads for governments is a new capability that also was released with Google Next. And it really, it goes by the title of simplifying the compliance configuration process and provides seamless platform capability between governments and commercial cloud environments. But in the end, what it really means is it helps government customers, suppliers, and contract to meet the security and compliance standards set by the US Department of Defense, the FBI Criminal Justice Information Services Division, and the Federal Risk and Authorization Management Program, better known as FedRAMP. In practice, what it means is, from a security standpoint, it allows you to enforce those requirements under those controls, such as data locality and personal access consideration, US citizenship requirements and so forth. It means that built-in security controls to prevent accidental misconfigurations so that your overall policies as a government agencies don't get violated at a project level basis. And it also means organizational policies that restrict deployments to only specific regions. You have much tighter control over your environments in terms of compliance. Now, what people don't quite understand is that, other vendors such as AWS and Azure, as an example, have gone to the model of building out separate environments for government clients. And the key to this is that they by building out a separate environment, they were able to put on the right level of controls and compliance around it. But it was very frustrating because these gov clouds, as they're called, have always lagged in terms of feature compatibility with what the commercial market had. And this is really the key, because for a vendor, a contractor, when you're building applications, you want feature parity between commercial and government clouds. It makes it very difficult for you to operate two distinct applications and operation supply chains because of the lack of feature parity, which will add cost, complexity, and risk to your environment. Now, the reality is, with assured workloads, you could access all of Google's services and capabilities, just as easily as for commercial, but without sacrificing functionality or service availability, but now do it in a manner that is fully compliant with all the rules and regulation that government agencies require. So, the idea here, in conclusion, is, you need to start looking at security in a much in-depth perspective. And when you look at what Google Cloud Platform provides, such as default encryption, VPC service control, access transparency, again, these have been around for a while, confidential VMs, you have the building blocks to develop environments that provide the highest level of security assurance while providing a high level of agility for creating business value. In my opinion, and I will put it out there as just my opinion, I do know Azure and GCP and AWS very, very well. I know of no other cloud provider, public or private, that operates with this level of security capability. Again, you have to enable it. It's not on by default, but with the right level of policies and controls around your environment, you could manage and operate these environments securely, likely better than your on-prem environment within Google Cloud. Thank you so much. And I think we're going to move on to a Q&A session.
Absolutely, yeah. If there's any, I don't see any comments in the chat, but if anybody has any comments or questions, feel free to put them in and we can address them as needed. But if not, I have a lot of bullet points to go through here. I'll give a quick plug about why Dido. If you have any questions related to any of these topics, Dido can fully support you, like we mentioned earlier, on Google Cloud, on G Suite, on Maps, on Chrome. So if you have any needs, business needs regarding those technologies, we'd be happy to step in and help support you. And if there are no additional questions, I want to thank everybody for coming, and we will see you in the next webinar.